Good morning, everyone, or good afternoon for those of you on the East Coast. Thank you for joining SnapNrack's webinar. Today we'll be covering SnapNrack RL Universal, the benefits in speed and logistics. We're going to go ahead and give everyone a couple minutes to join for those that are jumping on from another meeting or whatnot. So hang tight and we'll get started in a couple minutes here. Okay, good morning or good afternoon, everyone. Thank you for joining SnapNrack's webinar. Today we will be covering RL Universal, the benefits in speed and logistics. Today we have Ezekiel Ferguson as our presenter. Before we get started, a couple housekeeping items. Today's webinar is worth 1 NABCEP credit, so please give me by the end of the week and I will get out our NABCEP certificate for your participation, so that way you can get proof of credit there. Also, we will have a chance for questions at the end of today's webinar. So if you have any questions, please just go ahead and type those into the questions box on the GoToWebinar dashboard, and we'll cover those at the end. So as those come up, just go ahead and enter those and we'll cover them at the end. On that, I'm going to go ahead and pass the presentation roll over to you, Ezekiel.
Thank you, Jill.
Whoops. All right. Let's see here.
All right,
and we
looks
can
like
see
I've
your
got
screen.
it.
Yeah.
And all right, so hello everybody, welcome to this webinar. As Jill said, I am Ezekiel Ferguson, working with SnapNrack. Today we're going to be talking about the Railless systems and the SnapNrack RL Universal system. Let's go through the agenda real quick here. So first we're going to, just a little bit about SnapNrack. We're going to talk a little bit about residential mounting systems, in general. We'll talk about the benefits of Railless and, what you want to look for in a Railless system. Talk a little bit about wire management, aesthetics, and there's a little load characteristics chart for our system at the end of this presentation. We can talk about that a little bit, and then just the importance of support and training support, technical support, that kind of stuff, online support, whatever company might need. All right, let's get going. So about SnapNrack. So we started, it was a group of couple engineers and installers in 2007 working at REC Solar. Really wanted to make a racking system that was better than anything on the market as far as installability, user friendliness, and really kind of focus on little ancillary things like wire management, stuff like that. So they did. 2009 kind of went to market through AEE Solar, started selling it, and moved on. Throughout the years, we've had in 2016 reached 1 gigawatt of product out on the roofs. 2017 we had our first RL kind of system, and then in 2019 we got our new RL Universal and our new the UR40, the lighter rail that we've got, UR40 and UR60. Some kind of advancements there in rail technology, usability, and all that stuff. Continuing to innovate and bring new products to the market. And that's that's our main goal really, our mission is to maximize the efficiency of installs overall, and we really want to do that by we get out in the field, we get feedback from everybody on the team, really, from the guys in the warehouse to logistically what they're dealing with, and then but we really want to focus on the installers and what they're going through on the roof and trying to make it the best products possible to get them off the roof as quick as we can, and move on to another job, or get out of the heat and on those hotter, humid days. But yeah, so that's our goal, really focus on the installers, making sure they have an excellent product, and bring that to market. So we'll talk a little bit about just systems in general. So you've got two basic systems right now on the market right now. You got railed systems or railless systems. The systems that don't require any rail, typically you're going to have a direct mount. It's going to go right into the rafter. There's a couple options where you use maybe a deck mount or something like that, but for the most part, structurally they require you to go into the rafter, and that's really, it goes directly from the attachment point to the module. Rail-based systems, you have an attachment point, and then you've got the rail, and then you've got the modules, and the rail is more of an interface between the attachment point and the module itself, and that's basically because there is no attachment point, right? You've got to get to a rail, you've got to get to a rafter or something to attach your system to. And there's all different kinds of railed systems out there, light rail, heavy rail, different environments and that kind of thing. So the railed systems have been used for a very long time in the industry. That was initially how everything was attached. Years and years ago, they'd use unistrut and all threads and hanger bolts and whatever. But basically, that was the goal, is to get something on the roof to attach the modules to, because you can't attach them to the shingle or the tile or whatever it is. So get some rail up there, get some modules on there. It's fairly straightforward. You create a platform to drop the modules on, you clamp the modules to the platform. Pretty easy to train people to do that, and it works with pretty much every module out there on the market. And nowadays with the 2703, pretty much all these systems are integrated and bonded per row. So your mid clamps, your end clamps bite into the module, bite into the rail, and that whole row just needs to be bonded with a piece of copper, then run into the J-box. But you still have to add, you still have to bond the rows to each other one way or another. So one of the things that we think about too is how we can make an impact on the overall cost of the system. The inverters and modules have pretty much, kind of plateaued. There's not much, obviously we can't affect that. We can't make changes to that, but we can change, logistical costs, labor costs, less expensive hardware, balance the system. We can affect that by designing better hardware, simpler to use, easier to store, easier to transport, all that kind of stuff. So that's one of our goals with the Railless system. So the Railless system is somewhat new. It's actually, I mean, it's been around a while now. I'm pretty much most install teams, even if you're just installing Rail now, most of the crews have somebody that has installed a Railless product at some point. So it's somewhat new, but it's been around a while, and typically it works with a specific set of modules, meaning that you're not going to have an infinite range of modules. You're not going to be able to go from typically an older 50 millimeter module down to a 30 millimeter module. But the one of the major benefits of the Railless system is that it's got an integrated bonding. All these, and this is true for pretty much every Railless system. It's one homogeneous array. The whole thing's bonded with the clamps and the mounts and the links, and so one entire array facing south needs about 24 inches of copper attached to the module or one of the attachments, and then run right into the J-box. Pretty straightforward there, and that's true for pretty much every Railless system out there now. So as we were talking about, the Railless systems are fairly simple to install as far as attachments go, and typically they are binned into specific module heights. And we just talked about the integrated bonding, and that's true. You can kind of see there with that layout how the whole array is linked together and then bonded at the very end into the J-box. And then as far as logistics go, it's much simpler to transport boxes of hardware versus 13-foot long sticks of rail. Simpler in the warehouse for guys moving it around on the forklift. Simpler to deliver to the job. I always kind of use this anecdote when we were first testing the RL hardware, doing some pilot builds and stuff like that. I had enough hardware in the back of a Prius to install 8 jobs, and you can't do that with rail. It just takes up way too much space, too heavy, and too much aluminum. So if you're thinking about moving onto a Railless system, you want to think about what benefits you, and if you have crews that are familiar with the rail or Railless, you want to make sure that you have kind of a simple, intuitive design. You want to make sure that it works in your area. Some places, if you're on top of a mountain outside of Aspen, Colorado, or something like that, where you're at 8,000 feet and there's a lot of snow, you might want to install rail regardless. But for the most part, most markets are going to be, you're going to be able to install Railless without too much of an issue. You may have to go down to 4 foot on center, or occasionally 2 foot on center with the new design guidelines in heavier snow loads or heavier wind or higher wind loads. And one of the main things that you want to think about too is wire management. Does the Railless system that you're looking at have clear wire management benefits? Has that system addressed that? Is there hardware available to make it simple for your guys to install and not have to think about wire management too much? Regardless, with the Railless system, you're going to have to kind of plan it out. But once guys get used to it, it's pretty quick. And then aesthetically, does it look nice on the roof when it's finished? And then how much technical support is this company going to offer you? As you make a transition from rail to Railless, if you've got crews that are just not familiar with Railless at all, it really helps to have somebody out there to kind of show them the tips and tricks of wire management, how to use the hardware, and how to, get that stuff built quickly and simply, so they don't have to put too much thought into it. So with all that, that's kind of where we were. We ended up designing this RL Universal. It is very simple to install, typical with all of our hardware. It's a 1/2-inch bolt, and we stuck to that, of course. But what we did is remove any kind of interference between the links and the mounts. So if you've got a rafter that is right where two modules come together, you can just make some slight adjustments to the location of the hardware, meaning you can flip the mount on the other side of the track, or you can slide the link over a little bit, whatever it takes, but you don't have to swap parts, change parts, or replace anything. What you see in this image here is the entire system. You've got mounts, tracks, links, and skirt. Very straightforward, very simple to install. So like I was just talking about, everything goes in with a 1/2-inch socket. And really, when you're out on the roof, if you need to, you can have one guy installing, if you've got, 3 arrays, different portions of the roof, you can have the 3 guys installing each array individually. It's designed to be installed by one person. And as far as service calls, you can get back, if you've got, say, like a 4x6 array, and you want to get to that middle module because there's something wrong with the MLPE or whatever it is, you can just go out there and release the bolt and just lift the module up. Undo the clamps, undo the links, and slide the links over, and lift the clamp tops off, and the module will just come right out. And again, so we've designed it so that everything is done from the top of the modules. You don't have to reach over the module and tighten anything, or underneath the module and tighten anything. It's really designed to be a bottom-up install, and which, it's safer for the guys. If you're on a 45-degree pitch roof, the last thing you want to be doing is reaching over 40 inches of module trying to tighten a bolt or a clamp. So here is the component overview. I was just talking about it a little bit, but we've got the mounts over there on the right-hand side, or sorry, on the left-hand side, and then the skirt on the right-hand side. In between there, we've got the modules, or the module spacers, skirt spacers, and we've got anything you can install. Right now, you can install anything from 30 to 40 millimeter modules with those spacers. And what the spacers do is snap onto the leading edge of the links or the mounts. And what that does is, when you clamp the skirt down, that provides that initial height set for the rest of the modules to be installed. So if you can install 35 millimeter modules, you'll take those blue spacers and clip them onto the links or mounts in the very front, attach your skirt, and as you attach that skirt, it'll clamp down onto, as you clamp down onto the skirt, it'll create a space of 35 millimeters for those modules to be sleeved in on the uphill side of that clamp and link. This is a kind of quick picture of what I was talking about as far as minimizing the need or removing the need altogether of having to replace or exchange or change parts when you've got interference where there's an attachment point right where you have modules being linked together. What you can do is rotate the mount 180 degrees, so you can either attach it on this side of the track. Over here, you can see this on this side of the track, or you can flop it and attach it on the other side of the track, depending on exactly where this mount or where the link is. If it literally is right in the middle, like we've seen here, you can just butt it right up against the mount, and you'll have 1 inch of link clamped onto the module, which is totally acceptable as far as the engineering goes and the loading characteristics of the system. We also have kind of developed a sealing technology that is fairly robust. We've got a umbrella, a stainless steel umbrella with a EPDM washer inside there that's shaped to fit inside the umbrella and then over the cone of the flashing. And when you tighten that down, it kind of compresses everything together and creates a watertight seal. So as you install the first row of modules, or any row really, but you can adjust the height up and down the roof just by sliding it up and down the track, and you can level and line that front row. So you'll place the mount in the track. You can either rock it in as shown here, or you can slide it in from the top or bottom. So you're going to position it up and down the track, and then you'll tighten the bolt here that pulls the channel nut up into the flash track. So you'll tighten the channel nut bolt, and that kind of fixes it in position here. Pretty straightforward. As the links and mounts are clamped onto the modules, we've got bonding features here, so you don't have to add any jumpers between rows or anything like that. There's bonding clips in the links themselves and on the mounts. And you can kind of see here we've got these little pins shown, so you guys can get a good look at that. And that bonding pin bites into the module a little bit, and then the path creates the bonding path between the rows of modules. So a little bit more about the skirt spacers. Like as I said, they kind of set the height for the system, depending on what modules you're going to be installing. And the skirt itself is very, how do I put it? It's very robust. You can easily rest your hardware, your tools, stuff like that on it, and that's kind of what we recommend. If you're on a steeper roof, you get up there, you get that front row of attachments down, and install your skirt, clamp it down tight with the spacers set for your module height, and then you go ahead and start installing the rest of the mounts and attachments on the roof. And actually, I'd recommend, especially on a steeper roof or any roof really, attach all the tracks and flashings and all that stuff. Get the up to the track down first, and then you want to kind of hold on to the mounts, maybe in a bag or something like that, and install those as you install the modules. That minimizes the potential for your rope to be snagged up on any hardware or anything like that. So we'll talk a little bit about wire management. It's fundamentally different. It's not that different, but it's fairly different from a railed system, in that when you install that rail, you install our UR40, UR60 rail, it's got a channel, and you can use that channel to manage all your PV wire, your trunk cable, that kind of stuff. Basically creates a raceway right to the J-box. Without that, you're going to have a little forethought, little planning, that kind of stuff. And we've gone through that. We've got hardware for that. But with the MLPEs, that's going to be attached to the module, and all of your wire management is also done in the module itself. And there still is a channel. It's turned 90 degrees and points typically down the roof, because you're going to be managing those PV wire up inside the module frame. And that's kind of the best way to think about it, is there still is a channel. There still is a very usable space for all these PV wires and anything else you need to manage, and that's inside the module. So here's an example of, you've got one full array. You leave, as you install it, the top corner module is the last module that goes down, and that's where you run your last little bit of copper right to the J-box to finish that grounding of the array. So we have J-boxes. We have all these kind of things that we've specifically designed to work with the Railless system. J-boxes, wire clips, ground lugs, all that kind of stuff. And it's all, ready to go and can be simply attached to the roof with a little forethought of where you want to lay this out. So one thing we did was we developed these, some people call them W clips, but they're just because they're shaped like a W. But what happens is when you clip it on, the open end is faced inside the module frame. And what that does is create a situation where your wire can't be pulled out as a clip when you install the modules, or you have to make slight adjustments or stuff like that. If you've got a hanger and you want to pull it tight, you can, and the wire won't come out. It's, both of the Smart Clip XL and the Smart Clip have aggressive teeth that bite into the module frame lip, and they're fairly difficult to pull off of the module frame, which is what we wanted. And they provide a minimum amount of friction on the conductor itself, enough to hold it in place, but enough that you can, but not so much that you can't pull it tight if you need to without actually scraping the shielding or anything like that on the wire. And that's, typically where you want all your PV wires, up inside this module frame right here. That keeps it off the roof. It keeps it secure from, anything that might happen to it, the 20-year lifespan of the system. So this is an example of managing the PV wire with a standard string kind of system. Here we have some sort of half cell module with the J boxes in the middle. A simple way to do this is to, if the first couple times you're getting used to it, is you can just simply draw it out on the plans. And that's what I had these guys do. And they created a couple stacks of modules. When they're installing that first row, they'll call for a, negative on the right or negative on the left module, depending on what they're doing, depending on which module they're installing. And in this case, all of the, negatives are going to be on the left-hand side for this entire row. And then they'll have the one transition module at the end. That's what this module on the far right, that one stack, that has a positive at the top and negative at the bottom, and then they can just clip those two together, and then they install the next row. But you prep all this up you prep all these out at the ground. You stack them up wherever you're going to most convenient place is to get them up the ladder, pass them up to the guys on the roof, whatever it takes. And you're going to use the Smart Clips to do all that, and that make sure the wire is inside the module frame, it's tight, and it can't come out. When guys, typically it takes them a couple tries, but it's pretty intuitive. And once they get this down, they don't need to add any more clips typically if they do it, if they get this set up right. They can just take these modules, drop them in place, clip them together, and then grab another module and clip it in. Very minimum sagging. If there is some sagging, they can actually just pull on one of these little leads up here and just tighten it up if they need to. Obviously, they're going to have bags of Smart Clips with them, and if there's any major sagging, they can just add a couple clips or whatever it takes to make sure that that's taken care of. But the simplest way to do it is get this down on the ground, pass them up, and then just flat the glass down and clip them together. So most systems now are going to be using some sort of module level performance power electronics. And typically with a railed system, you're going to be attaching those to the rail, getting everything wired up, and then coming back with the modules and plugging them in and slapping them down on the rail and attaching all that stuff together. With a railless system, you're going to be doing the same kind of thing on the ground. You're going to prep all these out and get them ready to go so that the guys can just bring them up onto the roof, lower them in place, and then just attach the mounts and then clip the modules together. Just clip those MC4s right together right there with the tension already ready to go because everything's been prepped out on the ground. So here's kind of an example of that. The MLPE frame attachment kit that we designed has teeth right here that bond the chassis of the MLPE to the frame of the module. So again, you just got to add a little bit of copper at the end. It also comes with a smart clip to help manage the PV wire that's left over after you clip everything together. Take the module leads and clip it to the MLPE, and then the MLPE leads get clipped to the module so it's ready to go. And you can see here they've got the the MC4 heads positioned so that when this module is lowered, this side right here is lowered into the mounts, and then they lower the module flush to the roof. They can just clip it right into the next module. If there's any kind of sagging, again, they can just kind of tug on this a little bit, or if they need to, they can add a couple more clips. But it's very straightforward, makes the install very fast. We've also designed this little ratcheting device here. It's called the wire saver. It's a little plastic device that will pin a PV wire. As you see here, it pulls it tight up against the module. So if you've got a large array, you accidentally missed one of these wires and it's on the roof, you can get out there, use one of these, and it'll pull it tight up against the module frame, and it'll no longer be sagging on the roof. Which over cycles of wind or whatever it is, that you can wind, snow, whatever, dragging that PV wire back and forth across the composition, you're going to pull the shielding right off it pretty quick. So you definitely want to make sure all this stuff is tight up against the module and inside the module frames. So here's an example of that kind of operation. What a guy would do is get out there with a piece of copper, shape it so that it can hook onto the PV wire, pull that up so that you can get the wire saver end right here, the little teeth of the wire saver, and scoop it up with that little fork. Just scoop it up and then pinch it closed, and it just ratchets tight up against the modules, like you see here. Pretty cool. It works out, really well. Typically, guys, if they've done anything right, obviously they won't have to use it, but it's a nice little trick to have in your tool to have in your bag. You definitely don't want to be having to go back and undo modules just to get a wire. This, yeah, definitely a cool little device. So I'm going to go over the installation procedure. This is a couple. So one other piece of hardware we do have is it's called a ridge extension, ridge mount, if you will. Not just used at the ridge, but anytime there's skylights or something like that, vents that you need to get around, you can move the position of that flash track underneath the modules more, so that you can get the flashing installed correctly without bumping into vents or skylights or ridge caps or whatever you got, whatever kind of situation you're trying to deal with. So basic installation procedure. We'll assume that you've already found your rafters, you've done your layout. And with the layout, I typically, if guys are not familiar with the system, I typically recommend, laying out all the modules with chalk, if they're not familiar with the system, and if it's a complicated system, and they're learning how to do it. It just helps understand where to place the flashing and the flash track and all that stuff, what course of composition to choose. That kind of gets back to the support that we offer as far as getting out of the field and helping any, the crews get up to speed as quick as possible with training from SnapNrack. But so we'll assume you've done your layout, you've got your rafters marked, and you're ready to go. So you go ahead and drill your pilot hole. You'll use a pry bar to loosen up the flashing, or loosen up the composition, and put your flashing in place. Make sure it fits. You'll go ahead and pull that out and put some sealant down. Fill the pilot hole with sealant, and typically a little donut around the pilot hole. Take your flashing, place it back over the pilot hole, take your flash track, put it over the flashing, and drive your lag into the rafter. What we recommend is a 2.5-inch kind of nominal embedment into the rafter. So you need to plan that out. if you've got a little bit of decking to go through, maybe some skip sheeting, you may need longer legs, shorter legs. If you're going into shorter, shallower decking or whatever it is, but just make sure you get at least 2.5 inches of embedment into the rafter to provide that adequate uplift resistance. So you've got your flash tracks installed, and you're ready to come down and put your mounts down. So this is an example. You can rock, again, you just rock it in place or slide it in place, tighten the clamping or tighten the channel nut bolt, and it can be positioned either side of the flash track, like I was showing you earlier, to avoid any kind of avoid any kind of interference with the links or anything like that, if you happen to have a rafter right where your link is located. So you install that first row. What you're going to do is take the leading edge of that mount, and you're going to align it with your corner layout mark, and then tighten the channel nut bolt. You're going to do that to both corners, and then you're going to run a string line. And we've got features on the mounts, a little cleat that you can wrap the string line specifically for a string line, and it helps you kind of level that out. So you'll pull it tight between the two corner mounts after you've set those, and you do any kind of leveling. So there's a leveling bolt you can loosen up if you need to. It's set in the middle at the correct torque from the factory. So if you need to adjust it, go ahead and back that out. Move your mount up or down as far as leveling goes. As you install the middle mounts in between the two ends, you're going to move them up and down the flash track, depending on where, so you get this end right here where the cleat is flush up against the string line, and then tighten that channel nut bolt. So once you get all the mounts down, get them all leveled and aligned, you're going to come back and you're going to attach your little spacers, depending on what module height you're installing, whatever module it is. So you just snap those onto the links and onto the mounts. And then you'll go ahead and put your skirt in the clamp and line it up with your array layout and tighten that up. Go ahead and install. What I typically recommend is installing the skirts, 2, 3 at a time, and then come back. You just butt them up against each other, tighten the clamping bolt, and then come back and install your links with the spacers on them. Here we've got a picture of a link with 3 spacers, and that's, I recommend using 3 spacers if you're going to be installing, if you're going to clip all the skirt together at once. So, and I wouldn't really recommend doing this unless the bottom row only has maybe 3 modules or so. But if it does only have 3 modules, you can take the skirt and maybe use the links together and link the whole skirt together as one large piece and then place it into the clamps. But if not, you can just use 2. That's perfectly fine right at the bolts, and then 2 spacers, that is, right at the bolts, and drop that link right on the skirt. So as the modules, so you've got your skirt installed, and that's kind of what I was talking about earlier. Again, is if you've got these steep pitch roofs, you really want to get up there and get that skirt and front row installed pretty much right off the bat. It just provides a nice kind of catch for things. You accidentally drop your impact driver or whatever it is, boxes of hardware, stuff like that, just to rest it on. So get that up there first, and then you start installing your modules. So you'll drop the leading edge of the module into the skirt, into the mounts, and lower it onto the roof. And then you'll take your mount and slide it down the flash track and position the clamp on the module. Make sure it's flush, and then you will tighten up the channel nut bolt and then tighten up the clamping bolt. And all that's done, right in front of you. So you don't have to reach over the module and tighten up any bolts or anything like that. It's designed to be a clamp sleeve operation, so you clamp onto the module and you sleeve in the next module, so you never have to reach over and tighten up those bolts. So once it's, again, this is the same kind of going over that operation again. So once it's seated onto the module, tighten up the channel up bolt and then tighten up the clamping bolt. And this is kind of what the finished install of that first module will look like. The next module obviously goes right next to it. There's a little spacer that provides a space in between the modules. It's a nice feature to have. It's not absolutely necessary, so if it accidentally gets kicked off under the array or drops off, it's not critical. There are marks on top of these links to also help you align everything up. So what you'll do is you'll drop the module into the mount and the links, whatever happens to be, or two mounts or whatever it is, at the bottom edge, and you'll just kind of slide it over a little bit till it hits that spacer, and you'll lower the module to the roof. Go ahead and slide your clamp down, attach your links if you need one. And that's the second module being installed. And you just follow that same procedure all the way up the roof. So now you've installed your first row. As you install the second row, you'll sleeve it in place. You'll lower the module to the roof, and you'll slide your clamp down onto the module and tighten the channel nut bolt and tighten the clamping bolt. So one of the things as you transition to a new system is kind of the importance of technical support and training. You want to be able to get your installation teams, your design teams, whatever it is, up to speed fast. So you can get your permits, get your builds going as quick as possible. So if you're transitioning from Rail to Railless, you're going to end up with new layout strategies. I think that all Railless systems are going to lean towards a landscape install. So that's totally different than a railed system. You're trying to minimize the use of rail. You want to install everything in portrait so that you don't need as much rail. With the Railless system, you're going to want to install everything in landscape as much as possible because that's the best loading characteristics of a Railless system, because you're clamping now onto the long side of the module, and the short side is what's supporting most of that load. If you do install in landscape, or if you do install in portrait, which you can, you're going to have to typically reduce your attachment spacing from maybe 6 feet to 4 feet or whatever it is, whatever your loading, whatever your environmental conditions require. Typically, it doesn't increase the number of attachments overall, because you are installing more modules in a row in portrait, but you're also installing more attachments. In fact, it kind of balances out almost equal, but the issue is the loading characteristics of modules installed in portrait with a Railless system. So you really want to make sure you bias towards a landscape install. So that's, you're going to have that. You're going to have new wire management strategies. Like I just talked about, the training is critical there to get those guys up to speed. You want to get them, up there on the roof, installing modules as quick as possible, and making sure that you see the benefits of a Railless system as quick as possible. And design requirements, the jobs are going to be designed differently. Like I said, you're going to want to bias towards landscape installations. And we can go over that with your design teams. We can show them how to use the design tools that we have, all that kind of stuff, all that support that you might need, that we would definitely provide. So I was talking about this is a basic chart of loading characteristics. But for the most part, in 90% of the systems out there, you would be typically at a 6-foot attachment spacing if you're installing in landscape. So you can see here we've got a 40-foot snow or 40-pound snow load and 180 mile an hour winds, and that's if you're installing in landscape with most modules. That's kind of where you'd be at 6 feet, and you can see that that covers most areas. A lot of jurisdictions just default to 4-foot span anyway, attachment spacing, and what that does is allow them to kind of expedite the permitting process and stuff like that, or expedite the permitting process. But if you can install 6 feet, obviously it's better for the team, minimize the number of attachments. We also have design tools online that you can use to help build out a bill of materials. And the Railless tool that we have is, you can see here, you can make pretty complicated arrays and it still spits out all the hardware that you would need for that array, including the ridge mounts. These are the triangles at the top are the ridge mounts. And then all the other mounts are the same. This looks like it's an older image from an older system where it's calling out A mounts and B mounts. But there are no, it's just one single mount at this point. So you'd have ridge mounts at the top and then just mounts everywhere else in the system. But it will call out where you would need spacers and stuff like that too on the newer system. So you can choose different modules with our tool. All the approved modules that are available for the Railless system are embedded in the tool, so you can go ahead and select that. You can select your different design criteria as far as snow loads, wind speeds, all that stuff. And you can also choose different code sections, 2015, 20, I think it's up to 2017 now. Whatever you need for your specific HJ is typically in that tool. And if there's something else you need, you can definitely reach out to the engineering team, the SnapNrack engineering team, and we can work with you to set up whatever kind of process you need or help you need with the tools or any kind of support really you need to make a transition smooth and fast. So the other kind of last thing to talk about here is the aesthetics. If you can install arrays that look nice at the end, obviously the customer appreciates it. Every time this person comes home, they're going to look up at the array and they're going to see a system that is, it's got a great looking, perfect rectangle, everything's straight, and it looks, fantastic. And that's what they're going to see every time they walk home and go through that door. Also, if it's street facing, the neighbors are going to see it, and it helps as far as sales and stuff like that, just to make sure that everybody around can see that this is a fantastic looking array. And a lot of the way we made that happen is to make sure that everything had a nice, black finish. Everything is installed straight, and it really, it just looks great. All right, so that is pretty much what I've got here. If you guys have any questions, go ahead and type those into the chat box, and Jill can go ahead and feed those off to me if there's any questions you have.
Awesome. Thanks, Ezekiel. Great presentation. So While we're waiting for questions to come through, if you are not following us on social media, please go ahead and do so. It's a great way to stay connected with us, see what updates are going on with our products, also to see, what's going on with our team, anything like that. If you have any questions, please, now is the time to ask them. Today's presentation is worth NABCEP credits. Please give me till Friday and I'll get a certificate out to everyone that attended to show your participation so you can get your credits. Ezekiel, first question we have, can you explain more about what mount link interference means and how other manufacturers address it?
Yeah, so if you've got, typically we're talking about an interference where you've got a flash track. Let's just go back to that slide so we can take a look at this. Where'd that go? The interference typically happens when you've got a mount and the flash track being installed right where you've got two modules that come together. And the interference happens because you have to link those modules together. Some companies require you to actually pull the top of this mount off and replace it with something like a link. So if this happens, you'd have to remove a piece of hardware and add another piece of hardware. Now you've got a clamp that you can't use anywhere else, stuff like that. That's the typical way that people deal with this. What we did was we designed the hardware, the dimensions of this link, the length of the link, and the distance that this mount can flop back and forth, make it impossible for there to be any interference, make it impossible for there to be less than 1 inch clamped onto this module if you create a minimum no more than 3/4 inch space in between the modules here. And that's the dimension of the spacer that's attached to the links, that comes with the links, is 3/4 of an inch. So that's pretty much, yeah, that's it. Most companies deal with that by, like I was saying, removing a piece or adding a piece, typically something like a link to the mount.
Okay, thank you. Looks like we have another question here. What's your recommended install flow with RLU for a 3-person crew?
Well, I mean, typically they're going to build up their own communication, but I would, you have a guy working on a layout. While he's doing the layout, some other guys can be working on, prepping modules out on the ground or whatever it is. But once the layout's done, or if there's 2 arrays, you have the guy doing the layout. Once he's finished with that first layout, then the 2 other guys can come back. One guy can be finding rafters. Another guy can be following behind him, drilling pilot holes. Once the rafters are found, so you've got 3 guys doing, one guy doing a layout on the other side, and so same thing. Let's just suppose we've got 2 arrays. So the one guy's doing a layout on the other side, and the 2 guys are finding rafters and drilling pilot holes. Once the guy has found all the rafters, he can follow behind the guy drilling pilot holes and break up the composition. Probably at this time, the other guy's done with the layouts, and I got 3 guys, and then they would kind of all work on that same array and get it done, and then bounce over to the other layout and get it done. But really what you do is just cycle through the job. So he's found all the rafters. The guy behind him has, worked on all the pilot holes. And then as the guy finishes the layout, he'll come behind the guy drilling the pilot holes and break open the composition. And then once the guy that was finding the rafters has done all that, then he'll come behind and start applying sealant and sliding the flashings in place. And I recommend just, applying the flashings as you break open the composition all at once. That kind of helps. Or you have a guy come behind and, or place the flashing maybe without sealant, just so everybody knows that the flashing has been, the composition has been broken open, the flashing's been placed, so the guy ready with the sealant can just pop that flashing out, apply the sealant, and then lay it on top of the pilot hole and line it up. And then you have another, they cycle through, and then the guy comes behind him and starts throwing down lag down the flash track on top of the pre-positioned and sealed flashing. And that gets to the whole flash track placement. And I recommend getting all those down. You don't put any mounts in the flash tracks at first, except for that bottom row. So once they get all the flash tracks down on a normal pitch roof, then they come back and install that skirt. On a steep pitch roof, I recommend just putting the skirt in first. And anything above maybe 35, 40 degrees, just throw that skirt down first. And then come back and place all the flashings, flash tracks, and do all your, all that stuff. Once you get the skirt down on a normal pitch roof, or once all the flashings, flash tracks, and skirt is installed, it's ready for modules. So you'll come back, everybody kind of bounce off the roof, grab some water, and then start pulling the panels off and prepping them out. You can have one guy prep out the modules and two guys on the roof installing. And typically what they'll do is they'll just call down and say they want a negative up, negative on the right, positive on the right, whatever it is, whatever kind of install you guys, have, landscape, portrait, whatever it is, mixed orientation, whatever it is. The guy on the ground is going to manage all that and create the stacks and create the modules that you need for that install and toss up the correct module. Once he chucks that module up onto the roof, you go ahead and lay it down and you just snap the modules together. And then, and that's it. I mean, that's the two guys on the roof will just keep on installing. Once he gets all the modules done, maybe the electrician may be done hanging the inverter and running the pipe if it's really simple, and then maybe he can bounce out and start throwing modules onto the roof, and then the third guy jump back up onto the roof and start helping lay all the glass down. That's pretty much how I see it going.
Okay, thanks, Ezekiel. Very good answer, detailed. That is all we have time for today. Thank you all for attending. I see we had a couple questions come through. I'm sorry we don't have time, but we will follow up with you outside of today's webinar. Thank you all for attending and have a wonderful day.